Homework 10, question 2. So the question is asking us to find the definition of properties of a stochastic process. First one, the wide-sense stationary process. So a stochastic process is called a wide-sense stationary process if its mean is a constant and the autocorrelation is a function of time differences. So the WSS only use the mean and the autocorrelations. So based on the expect value, which is the mean and the autocorrelation function, we can do the state estimation, the parameter estimation, and the prediction in mean square sense. We know the autocorrelation function are T1, T2 for T1 equals T2. It's just the average power of the signal at T1. And then we know that if for a system that if the input is a WSS process, the output of a stable LTI system is also a WSS process. Number 2, independent increment process. This means that the two different intervals, that time intervals, which is xt1 minus xt2 and xt3 minus xt4 are non-overlapping intervals, will be independent. So far, we know the Parsons process, the random walk, and the Wiener process are all independent increment process. Number 3, the Markov process. So we said the stochastic process is a Markov process if the past has no influence on the future when the present is known, which means past is not going to be affect the future, only the present. So we know that the Parsons process, the Parsons impulses, the random telegraph, the random walk, and the Wiener process are all Markov process. Number 4, the normal processes. So we said a stochastic process is a normal process if the random variable xt1, xt2, all the way to xtn are jointly normal for any of the at any of the time. So as you can see, the representation as above, as below. So we know that statistically, a normal process is completely determined in terms of its mean eta of t and autocorrelation r of t1, t2. We know that in general that eta t is just a function of t. We know that we classify that the Wiener process is an example of the stochastic process, and we classify that a normal process is just is a property of the stochastic process. Number 5, so a process is said to be a strictum sense stationary process SSS if its statistics is not affected by a shift on the time axis. Number 6, the white noise noises. So for Wiener process W of t, we want to know the derivative V of t, which is the derivative of W of t. And we know the expect value mean of V of t is going to be just the derivative of the mean of the W of t, which is 0. And we know the autocorrelation is just R of T1, T2 is going to be equal to alpha times the impulse function of T1 minus C2. We know that the VT is going to be a normal white noise with 0 means and the impulse autocorrelation function. So number 7, a stochastic process x of t is said to be a mean arithmetic process if the limit of t equals to tau goes to infinity, 1 over 2t times the integral from negative t to t times x of t dt is going to be equal to the expect value of x of t in a mean square sense. Number 8, a stochastic process x of t is said to be a martingale if the expect value of x of t over xs of xf is going to be equal to x1 is going to be equal to x, where s is smaller and equal to t.